about to a game called Graphomata. This game has been linked around recently a couple times. Notably, I've noticed Leaving Leaves playing it. The only thing I know about this game is that it is a graph-based game where other games can be simulated inside it. So, yeah, let's get into it. Apparently we're making nodes, so this is a game about graphs. The colors and placements do not matter. It's all about structure, so let's build a node and use a command. Alright, so let's bring a node and then run the algorithm. There we go. So that's just introducing the way the inputs work. You drag into here, and something happens on here. Comparing. Structures are identical, yes. Okay. Oh, and we have cycles as well. So we get to compare scores with other people. Always enjoy when that's in games. All right. So let's see. Link is the next one. Build a basic structure. I unlocked Bob. Okay. Drag command. Well, we already have node A. Why would I want to node again? Drag the symbol B to the command. Oh, the change is to say node B. Okay, and specify the direction. So now A is linked to B as its next step. Then link A to B. I need to, like, do that. And there we go. So what is actually happening there? Oh, it's probably placing. Okay, so when I do node A, it places node A into the grid. And then B is placing B, and then link is linking A to B. Alright. Alright, got it. So again, basically everyone got the same score because it's tutorial. Chain. Okay, it's happening. You see this? Your solutions will be implemented in a different language. So as I know about just people talking about this game's programming language is going to be represented in like tons of other different programming languages as well. Okay, so I just need to build a chain. And okay, so do we have another one? We don't. This is weird. What happens if I do node A, then B, then A? I thought we were supposed to find okay, well, we don't necessarily need 3 nodes to make a chain of 3. You can just chain between 2 nodes. So link A to B. Make sure to link these instructions together, and then link B to A. Is that going to be enough? Let's try it. This does not match the goal. What if we do another link from A to B again? No, because the link already exists. Then what is happening? Okay, so that creates a node, then this is actually 2 actions at once. And the one that's important is the fact that we can create a new node and then get Alice onto the node. So this should work, right? No? Oh, I forgot to link. But yeah, that creates a new node and then moves Alice onto the node. I just forgot to link these together. Okay. There we go. And you can even see, like, the basic code on the right. Basic is, like, you know, pretty old programming language at this point. Hopefully you're aware of it. Anyway. Next level. Turn 3 nodes chain into a 4 nodes chain. That should just be adding another node. Okay, well, node A. Okay, so I noticed Alice is starting on here, which is not great. Like, no, okay, this makes sense. I just need to make a new node that is B, and then link B to A. B, A, there, right? A new node will occur, and then Bob will link to Alice, making a 3 chain go to 4 chain. Okay. There we go. Okay, so we've unlocked automatic directions so we don't have to keep linking, and a clipboard as well. Okay, this is incredible. Rectangular selection. I've always wanted this in my programming puzzle games, and this game is actually doing it. Okay, so we need to build a cycle of 4 nodes. We also have a new character. We also have this note here, like the right side is equal to the left side, because even though it doesn't look like it's a cycle, because it's a little bit scrambled, it's still a cycle of 4. That's what matters, not the physical way that it looks. What matters is that it's a cycle. Anyway. Okay. Clipboard, huh? You can change the node inside the toolbox. It's good to know. So that would be... You have to create a node, of course. Then create 2 and then link them together. I guess we need a 3rd character because we need the 1st character to stay. Like, eventually we'll need to link the last element with the 1st element. So a character must stay at the 1st element to be able to target it. So, anyway, we make C, node C, link C to B, We're going to need to make 4 links in total. The new node will be something that B moves to. No, that's not right. We have to reverse B and C because C just got added. And that means that because B got added, I believe it's C that goes to B. Okay, so that's our graph. Now we just need to connect B to A. So you can also use this X to swap, which is nice. So C, B, A.
Chess battles advanced.
Alright, let's do this. There we go. Slower motion, I guess. Alice B. Connect, connect, and then connect. There we go. Next. Yep, there we go. I wonder what the gold means. Surely it doesn't mean that I didn't do the best in these, does it? Okay, so now we need to turn 3 nodes into a 4-node cycle. We also unlocked walking. Walking simulator unlocked. Alright, let's go. So, we already have this much. We do not have access to Carol in this level. So, okay, immediately I want to create a new node and then connect B to it. So we can use this to swap. So what this will do is immediately bring this. And now we need Alice to walk to this and then connect to Bob. This is great because, like, the arrows are now meaning, like, they actually have more gameplay meaning now instead of just being a goal. I also like that you can pause this. Like, does that mean I can link A to B and then it continues it? Oh, that's great. That is such a great feature. I had an incomplete solution and it let me add more commands to make it complete. All right. All right. Wait, the level select is also a graph and it's directed me to level 9. Why? Who does this? Let's check out level 7, though. This is called grid. Non-determinism. Oh, nice. So, if there are 2 ways out of a node, like, you can see that this has 2 ways out. This is an element of randomness, and the game tries to suggest that you should avoid these scenarios. That does make sense. Probably gonna do something to protect having randomness in solutions, but okay, we need to turn this into a 2x2 grid. Okay, so the difference between this and the chain is that you can see that these 2 nodes are being branched outwards of green and then both going into blue. So let's put node B and connect to it. And even like show it right. Alright, so we made this connection. Now I believe I want... Okay, we actually have a problem because we can't connect back. Okay, I was wondering if this was going to be an issue, but notice that I can't bring anything into this node anymore because I need a node from Alice to connect to here. But if Alice moves, then nothing is here. And I can't get anything else to be on here. So we should actually construct this in reverse. Let's try this again. So let's make node B, connect B to A, then make node C, where B connects to C. Right. So at this point, we can see that all we need... Here's the better way to show it. How can I lock you people in a position? Here. Notice that all I need is for Carol to connect into the blue. So Alice should just be able to walk there, and then we connect Carol to Alice. Link C to A. Alright. There we go. Alright. I will say, this does have the programming puzzle game problem in quotes because it's not that easy to address, but the levels are too simple to currently have anything interesting with optimization. In basically all programming puzzle games I've seen, though, they eventually become interesting to optimize, but it does take a while to get there. Anyway, multiple solutions are supported. Okay. Your solutions will be implemented in Go. Go is another programming language. Okay, this time the goal is to turn it into a parallel chain. We have this chain at the bottom and this chain at the top, and they're also parallel connected. So it's a 3x2 grid. Why are there already like things in the grid? I didn't place these. Well, let's check what it's doing. All right, so it's kind of making parts of this already. I guess Bob just needs to go in here, make a new node where Bob is, and then Carol connects to Bob. Alice can walk. So what? Oh, no, that's fine. It's isomorphic, which means that this can just be moved outside and there's no actual change. Anyway, Bob connects to Alice. A, B to A. There we go. There we go. Okay, 4th, next level. Huh. Root. So you can gain commands that are not intended to be used in the level, and I bet they won't count as a canonical solution, but can help you with it. Okay, now we need just Well, it doesn't say a specific structure, but it probably is this specific structure. So I noticed that this node branches out to all other nodes. There's no arrow going in the pink's direction, only going out. Okay, well, let's do it. So of course we have absolutely nothing right now, and C is nice red icon background. So this is currently not in the level, and it's not canonically allowed. We also don't have walk. Walk is still not available even if I turn on root. Well, it doesn't matter. I don't need it anyway. We're gonna make two nodes and connect. That's basically forced. That makes this. So I remember that we had a node that wasn't connected to anywhere. We should just get that done now, I think. So we'll immediately bring another node and have it connect, and then we'll never use this node again. I think Bob will have to go ahead and make another connection. So then we extend, so Alice will go ahead. This will actually fail. Okay, if Alice makes a new node into Bob, then there's no way I can get into this node anymore. So I must back construct in some way. So let's get rid of some of these. So instead, we're going to switch this link to be the other way around. Then this time, Alice is going to be the one switching, and we're going to do a reverse link. I think we link this again, right? Something feels wrong about this. No, actually, Bob just... Okay, Bob goes, makes a new node, and then Alice can connect to Bob. There we go. So that was the structure that we wanted the whole time. So one central node with two branches that are length 2 and one branch that is length 1. There we go. Okay, next is Gapcha. We got one of these that are going in two-way links. All right, let's go. Yep, just that structure. How do I think about it? Like here, I think is the most intuitive. Put this down in the bottom right. We don't even have walking between nodes. You know, I think I already visualized this entire thing in my head. I'm not even kidding. Like there's no reason to actually do this level. I just know I'm going to start here. B is going to be this way, and then we just swap B, A, swap A and B. Basically, the entire thing is just going to be swapping characters over and over. And so I'm not even going to show the slow process of placing the nodes. All right, I made the double link. And I believe this should do it. There we go. Yeah, that was just a busy work puzzle. There we go. Okay, here's level 11, where I need 3 merge cycles. All right, and we start with an input already. Well, first of all, I want to rotate it so that my conception of where the rightmost is with Alice on the bottom right. Then I'm going to make a top right one, I think, which will connect to it. Then Alice walks, and then B connects to A. What the? Oh, crap. Right, there is some deterministic problem because we created 2 possible exits, and so it's random now, which we should not allow. Wait, the arrows are actually wrong in the... Oh, no, hold on. The arrows are wrong in the way I've rotated this. Okay, I rotated it correctly now. So I guess let's try to make the bottom right location instead in the finish. Instead, we have a link from B to A, which corresponds to the bottom right in my image. Then I guess Alice can come and make a new node, which connects to Bob's but doesn't come back. Bob can then move, and then Alice can connect again, right? So now all that's needed... Let me switch this. It looks like the last link was incorrect. But then, okay, can Bob move now, or... I think Bob can't, like, Bob is moving towards 2 different directions now. This is hard. Do we need Bob to walk even more? I'm really worried about that inefficiency if that's true. That would make it move there, and then we could connect to it. Okay, then Bob can just walk to the end, right? Then, can connect into... Nope. Switch it. There we go. So let's see if that was efficient, huh? Unfortunate. So gold doesn't mean the best then? Because clearly I could have done it with less commands. Okay, stared at it for a minute and I have a better idea. The key is just trying to make moves that still allow you to walk in useful directions. So that already makes the middle correct. So now Alice just needs to move. Alice connects, B walks, and I think it's just B connects to A. There we go. Much better. Well, I can't believe I lost my more cyanic color to a blue. Anyway, I'm sure you're dying to see some of the new mechanics, so let's start. B1 join. Right? Pascal, of course. Now workers can join with each other? I wonder what the point of that is. Like, I would have thought there's nothing good about being on the same space, but I noticed that node A, the node is not currently available. So maybe B join A, and that makes B come in and then go on the same space. Alright, so now A just walks to this, and we link it. What? Oh, I messed it up, and it should be A to B. There we go. What was that with okay, thank you, Pascal. Alright, here we go. Double link. Alright, build a doubly linked chain. Can you stop moving around? Alright, so this is clearly like B join A, and then we continue to walk and just cycle. Okay. And then I guess A and B then walk. Okay. Oh, C is also here. Actually, I was wondering, like I just stared here wondering why we need 3 characters, and I realized now it's because making this link will cause the walk to be in 2 directions, which I kind of allow. So we're gonna have to, like, create C to join A, and I don't know, C walks forward, A walks forward, doesn't matter. So we don't have that problem. And now, C can link to B. This is getting a little bit sus in like the idea that it could loop back on itself, because I notice this process is going to be repetitive. I'm gonna try to link the other things up, but I fear that I'm going to be over, or at least like not optimal. Anyway, when they walk, Carol and Alice can connect now. Carol can join Bob and walk. B can connect, and C can connect. Okay. Oh, wait, it was 12. Okay, thought it was 11. Okay, well then. Alright, well, next one. Unlink. Wait, that's a thing now? Remove a link. Build a cycle from a star. Okay. So we already have this exact number of nodes as the solution. We just need to rearrange the links. Alright. Also, they're... like, this is way too many. We can't have 3 coming out of one node. It must be only 1 from coming out from each node. So we need to unlink 2 things here. We just need, like, characters to come in and join along. So we'll make B and C join A. B can walk. Actually, this is a level where even though we're walking in random directions, the nodes are basically equivalent to each other, so it doesn't matter. But, okay, B will walk to a random node. And then we unlink from A to B. We'll then do the same for C. Here. We should be able to just link the rest up now. B to A. Okay, you can double link the nodes in this graph, which is a spaghetti idea, and it introduces a new instruction in the Go section. We don't need to deal with that for now. C, B, and then A should just be able to walk, and then A connects to C. There we go. A little bit slower. Carol unlinks, and then we all set the rest up. There we go. Someone got it with 2 workers? I can imagine the solution, like, there's no way the solution is the same one as the one that's getting the better command scores, right? Okay, just gonna try real quick to do it with only 2. Alright, so here is something that's really close to the solution. I unlink that, move, and draw a link between here and here. Extending it, and now Bob can just move. And Alice can connect, right? Or not Alice, but Bob connects to Alice. There we go. 2 workers. Yeah, I mean, I'm sure that if you see that you can solve it with 2 workers, you would just do that. Okay, B4, which is a red icon. Dispose. Oh my gosh, what does this say? Workers are home. I guess this is... home is a place where the workers, they're like their spawn room in an FPS game. So if there's no path when you walk, you return home, and when someone is already at home and another character tries to join them, they also go back to the home. And then I guess we have a character that is specifically reserved for people to, for other characters to join them. Okay, so what's this level? Dispose. Okay, remove the entire chain and the nodes in it. Wow. What's this? If I click the clipboard, I can put stuff inside. Wait, all right, that's ridiculous. So that's ways to grab commands you really shouldn't be able to grab. All right. I imagine it's not going to let you. Nope. Okay, so is there a problem if I do A join H? Nil. Nil? Alright, so I knew H had to be some sort of, like, special command. Maybe it's just the pointer to the empty spawn area. Spawn area is my attempt to get an analogy of what a null area is, though. So if you do that, you can actually move A to the nowhere zone. What just happened? Oh, it changed languages to go. Okay. Anyway, we're going to need to have characters to... And we cannot... Yeah, the null character, aka H, cannot move. Because it isn't even really a character in the first place. Okay, so we get Bob in here. Bob, Alice moves, and then we break the link. Oh, direction freaking matters? Alright. Now, Bob should... Okay, so does this disappear if no one is in it anymore? Let's have B join A. And it's gone. Alright. I tried looping, and you get an error when you try to unlink from B to home. So let's not do that. Okay, so... that happens, and then Alice and Bob are just sitting there. Is it just that A needs to join home, and then B needs to join home? Is that all? Oh, come on, not a for loop. There we go. There we go. Okay. Level B5. Turn a cycle. Turn this into a chain. Scenarios. Okay, so this is probably going to... What is this? Select scenario. This looks exactly the same. Like, I imagine this only exists for RNG protection, but this is still strange. So, seems like we need something to be on this node at the very edge. So we need a character to join and walk over to here, then go here, but that requires an unlink first, I think. Does, I guess C also joins. What happens here? B should then continue to walk and then link with A. Link A and B together. Now A and C link back together again. No, not join. No. Okay, link C to A. There we go. So what is the other one? Oh, it works on all scenarios. There we go. This does not look different. I don't think they look different in any scenarios. It's okay. It is, as I said, it was just RNG protection. All right. There we go. All right, let's go to level B6 now. Triangles 2. 3-node cycle, which already kind of looks like the goal. Except, I noticed immediately that walking out of A will be very strange. Like, there's 2 ways out of A, and I can only hope that they're symmetrical like that somehow. So that the first walk... We absolutely need to do a first walk, so it has to make sense from both directions. I think the only logical thing to do here is to start with getting C and B on A, then sending each of them over and unlinking. Walk B and C, then unlink, so that C is in the same spot. Right, how do we distinguish them, though? This could link A back to B. Oh, I really hope this is isomorphic. I think B needs to walk for them to be equal. See, from here, I don't know if I want B to walk and make Bob and Carol equal. It doesn't matter if they're equal. You just get rid of that, and then make B into a new node. Now, the goal involves, I guess, B connects to C. No, B definitely has to go and walk, I think. B has to walk and connect to Carol. Or the other way around. Whatever. And then link here and here. And this still doesn't account for the fact, like, what if I messed up my connectivity? Well, I guess, during this walk, we don't use A anymore, so A should go and join up with where B ended the walk. Restart. And now, isn't it just Bob connects to Alice? What? Sure, flip it. Okay, this worked on this scenario. Does it work for all of them? Hey, look at that. All right, cool. Oh, wow, what is this? No one has ever got it with 12 commands? All right, chess battle advanced. That implies that, like, we did something that was really easy to remove one command from. Oh my gosh, it's this step that's nonsense. Alright, sorry that it took like 2 minutes looking at the screen. And like a few more minutes of idle time too, while I was not focused on the game. Anyway, it's that A doesn't need to join with B. A can simply be the one that comes and makes the new node. Hold on. I need to refresh these, of course, at the very end. So now Alice can just connect to Bob and Carol. I think it's like this. And there we go. Alright, let's go to the levels again. We have, okay, B7, link structures. What is that? What? We're doing math now? Form long chain. Alright, so we have to break, like, I noticed that in each of these parts, we have a chain and a cycle. So we need to break part of the cycle off and then connect it to the chain. Alright. Inputs. Let's look at this. We have 3. Look at how many inputs there's gonna select from. Obviously, we're not doing all of them manually. So, it doesn't matter where you are in the chain. They're basically equivalent. This is really weird, though. How do you, like, check? We don't have conditionals, and, like, this is one of those kind of annoying, not very open-ended languages where errors happen a lot if you don't do things the right syntax or if the move is not possible. So basically the question is, how do we figure out the length of these when the lengths could be anything? The same program has to work for all possible scenarios after all. Do we just spam, like, what's the issue with spam walking? It does not reside on node, so there's no way to exit this. Wait, no, okay, I exited immediately, okay. It was funny because, it's funny I was stunned into not feeling like anything was possible, and then I immediately understand. So first of all, let's get C over and make C walk. And we're also going to break that link between B and C. So now, we basically have a chain right there. B just needs to connect to A. There we go. Chess fight next. Alright. Let's see, the next is B8. Seriously, this is a mega wheel. Bigger algorithms? Alright. Doubly linked wheel and extend it so if it has an extra node. Okay, so everything, I see everything connects to a center node, and we call that a wheel. Alright, whatever. Why do we have so many possible characters? What is this button? Nice layouts. Okay, we can... Fine, we can make B join A. I'm pretty sure we need to keep someone onto the center. Then A will walk, but it will be in a random direction. There is only one exit out of here. We want to break it and then add a new node in between. It doesn't matter where Alice is, because any of these points don't really matter. We just need to insert one extra. So we'll have C join A. C can walk through there. We'll break the link on both sides between A and C. No, why did... Okay, that's a problem. Oh, no, we don't only have one. I was so wrong. We don't only have one wheel. This of course, it's doubly linked, so it can go in any one of 3 directions, not just one. So that feels like it's going to be annoying. Having to unlink all the directions to force one certain direction. It doesn't matter which direction you go. So really, we should just be able to... Okay, here, we should disconnect with Bob. Nope. Unlink first. Okay, let's reconnect Alice and Bob using a link. We also want a new character to fill in the gap that was just made. AD, the reverse of AD. Oh, it auto-reverse, that's cool. Link with AC, and it should just be link with AB as well. No, what the? Oh no, freaking D is the common factor here, not A. Duh. Okay. There we go. There we go. So there's like no difference in solutions for all the players. There's nothing else to do there. Okay, B9 condition. I think we're finally gonna get a conditional test. Okay, Okay, this can branch in two different directions. Switch between a 4 nodes chain to cycle. X to exchange. So that can swap their positions, I believe. Alright, so this is a multimodal kind of thing because some inputs will be chains and some inputs will be cycles, and we need to switch to the other one. Alright. Play. So the only real difference between the chain and the cycles, there's no link between here and here. So if we get Bob to join in and then move a bunch of times. I know Alice is moving here. In this situation, Alice goes back to the home because there is no link. That means it will fail the test between A and B. Okay, so let's set a yes for this. If A and B are on the same node, which will happen if there was a linkage, then we want to unlink it. Except there is no linkage because Alice would have moved. So let's, over here, let's get Carol to join with A. I'll need to reorganize this, hold on. Well, we should do it on a no case first, because we're currently on the cycle switch. Alice is not on B. So, then Carol should link to B on the no case, because the no case happens when Alice is not on Bob's node, which is currently true. We also need to prepare something for the other case, where I believe Carol needs to unlink. Okay. There we go. Let's check the other case now. There we go. Okay, what is this one worker what is this? No, I don't think anyone wants to be there. It seems like it's possible to do it in 3 workers. I mean, not 3, but 2 workers. But it's not like the best solution or anything. There's a fewest command 7 hiding around here. Now, world C seems like a small world. I don't know. But alright, what's overflow? Fortran. Right. Okay, it's a loop structure now, yes. We want to cause an error, and that's a success in this level. Okay. So can we just create more nodes, or does it not let you? Like, I know that if you do this, maybe the nodes disappear because they're not being used. Yep. Okay. But that isn't a too complex structure. It's just an infinite loop. So I believe we need to link so that they actually count as structures. So let's link A to B and just continue linking somehow. But can we just keep doing this? How amazing. There we go. So success. Too many nodes. There we go. Oh, and there. Okay, wow. So, yep, I got the solution everyone else got, but there is a solution with fewer cycles. Let's try to make that happen. Put our previous solution down here. So I imagine this is just a sort of unrolling, or like we can't make an easy 3 loop, but we should be able to make a loop with more than that, and then like connect them all together. B connects to C, and then link up. So what does that do? I think it should create constant loops of 3, and then they all go to a new place. Nope. Why? No, because I need to set this up. Okay, here. Make loops of 3, and then go to a new place. So this should be more efficient. There we go. Trade-off, there we go. So we finally got an achievement for getting a different kind of solution, which is worse in commands, but better in cycles. Like, apparently it could do even better than that. Like, as a reminder, we need to link so that the nodes stay in the graph, otherwise they just disappear. You know, I've become a little more aware that, like, the A, B... This was actually a good thing. The A, B, and going over, it's just that we're going to need to unroll it a little bit because there's no way to do an easy 3 cycle. I wish there was maybe, like, a diagonal connection feature or whatever. Just something I suggested for another programming puzzle game with a similar grid style. But okay, we should just loop this. And now we have a 3 cycle, which is something that should be much better. There we go. Alright. C2, nearly dispose. Hmm. At most one? Hmm. Why? Is there no way to make sure it's empty? So it's either 1 or 0. And it's any number in the cycle, alright. Alright, so the first move is forced. It's B, join A. Gonna move it there. So, and then one of them has to walk, and then, but we're gonna unlink stuff, obviously. Feels like we should just be looping characters to go ahead, unlink, go ahead, unlink. It means that it should be Alice doing these instead, in case I wanted a good loop. Let's just loop this. Make A walk, and then unlink B to A again. So what's wrong with it? Success! There we go. So we just moved, went ahead and unlinked, unlinked, unlinked. Now I know this is spending 6 commands for something that really should take 3, just because we can't 3 cycle. Okay, so I got the best in cycles, but 4 commands. Obviously 4 commands was possible. What's this? They even got like 4n plus 3 calculations. Okay, might as well do the easy 4-1. Imagine this is just wasting a turn so that we can get... There we go. So we're wasting a turn to say B join A twice, just so that we can get it in 4. In a loop of 4, that is. There we go. Alright. Oops. Yeah. Dispose cycles. Dispose of an input cycle having... Wait. Verbosity level of code. Okay, so now this is like a real disposal, huh? So do we have like the conditional now? Yes, we do. So the conditional is the way to test it. And you can see where we have the normal background again, so we're not waiting. The level doesn't let you end on an error anymore, so we have to end normally using a test. But the test probably goes in a loop. Let's copy what we did before, only with a test at the end. Actually, shouldn't the test be checking that B didn't walk off the grid? So we test home is equal to B. So, we're gonna test no, and on the yes case, this is weird. The yes case should just leave the grid, right? Or no, when yes is, if B walked off the grid, that means that A would be sitting on a single node. So A needs to walk off the grid, but there we go. I think this should work. What? The wrong direction. Ah. Okay. What is wrong with my coding? Is it that Alice should be the one walking? Alright, there we go. And now the final step. Alright, so the issue is that I tested H with B and that should be A. Let's refresh that. And the final step, Alice is on home, and the test changed it and got us out of the loop, then made me walk off. So there we go. Some players seem to score, can't even check that. Alright, well, that was an easy one. We should go to clone now. Yeah, I don't know if you want me to skip levels. I've just been doing them in order because I've constantly always done that. Python code now. Build a duplicate copy of the input chain. And what is this, breakpoint? I think breakpoint is just for user input. It doesn't have any mechanical meaning. So we know that it's a chain. So at least we're not copying any random structure. So we probably just do the same as the last level where we... Well, no, we don't. We just walk. We walk. We test if A is home. Well, first of all, we need to make a new node. I believe we don't have 0 in the input case, right? Yeah, it's just n equals 2 is the minimum. I wonder if that means we could save little on tests. Because we know the first one it won't walk off. Anyway, we make a different node. We make walk. And if we didn't walk off, then we should make a new node and connect it to B. So link B to C. I think that means B can walk forwards after that. Should be the no condition. What's the Python code here? Like, oh, we can't even change it. The verbosity. Screw that slider. Anyway, if A is not at home, can we just say yes? And this is no. Alright, let's check this. What does this do? Okay, that was a success. We should check it on other inputs. Like, let's 5. So, every time Alice walks, we should make a new node, and then walk to it. Okay, look at this. And there we go. Cycles. I knew cycles could be a little lower. I almost don't even want to bother with that, because I know it's some probably unrolly stuff. You could definitely save cycles with using multiple players, because there are definitely ways to use multiple workers there. Okay, what is this histogram? Anyway, we got the maximum score, so screw that. Double. What? No, let's not read the keyboard shortcuts. You don't need to worry about those anyway. Double the number of nodes in the input chain. Okay, that should be easy. First of all, we need someone to join A. And we're probably going to be back adding. So every time A walks, we back add. I wonder if this will cause any problems with the amount of characters that can be there on the back of the chain. Anyway, no. Anyway, let's look at this. When you walk, we should make a new node and then connect it to B. Then we should update B's position to be where we just added that node. So B join C. But we also need a test to make sure that A doesn't fall off the grid. Oh, there we go. And then we loop, I think. Just loop. Gonna be a problem. Yeah, okay, we need to swap to freaking yes and no. What do you mean output does not match the goal? There's gonna be a classic off by 1 where, like, it's supposed to be 5 and 5, but I made 5 and 4. Never freaking got the intuition for that, even though I understand the concept. Okay, let's try this. There we go. So instead, every time A walks, then we make a new node and add it on the end. Okay. There we go. Alright. Oh, geez. This freaking C has like 11 levels. And so no surprise, the window is the map is far bigger than it looks. You even got level X1.